So today, good morning to all of you. So this is the fourth block of MEV 001. So in the previous block, we studied the different types of pollution, the ecosystem, ecological pyramid, then the food chain, food web, air pollution, soil pollution, noise pollution. Then in the previous class, we studied about the radiation, then the difference between noise and sound. Then we studied about the e-waste. And in this block, so we are going to study the assessment and monitoring methods. So again, similar to the other blocks, so here also you have 4 units. So the first unit deals with the environmental quality assessment and monitoring. And the second unit is regarding the water quality assessment and monitoring. And the third unit is the air quality assessment and monitoring. And the fourth unit is the soil quality and noise assessment and monitoring. So the what we studied in the previous blocks. So in this block, we are assessing the quality and monitoring. So now first let us take up the first unit, the environmental quality assessment and monitoring. So as we discussed in the previous class, environment is defined in different ways. So environment is the complex physical, chemical and biological factors which acts on an organism or a community, and ultimately it determines the survival. So there are 4 different major components of environment, like hydrosphere, lithosphere, atmosphere, and biosphere. So it consists of environment is consists of both biotic, that is the living organisms, and the abiotic component, that is the physical component. So deterioration or degradation of our environment of our environment so impacts. So deterioration of our environment, it affects the health and well-being and the quality of the environment. So hence assessment and monitoring of air, water and soil, they are very important and it is discussed in this following units. So what is this environmental quality? So similar to the quality of other, the non-living elements. So the environmental quality means it is a set of properties and characteristics of the environment. It measures it measures the conditions of the environment relative to the requirements of one or more species to the wellness of the human being. So various standards have been set by the government, private and international agencies to monitor the quality and to improve when the limits are exceeded. So the main tools to manage the environment are, first one is, so the quality of the environment is assessed by environmental impact assessment, and the second one is environmental legislature. So first coming to the environmental impact assessment. So in short, it is also called as EIA. It is a process. So as the name itself indicates, the environmental impact assessment. So assessment of the impact on the environment by a project, by a program, or by a plan. So it is one of the important management tool for ensuring the optimal use of natural resources for sustainable development. So beginning in this direction, was made in our country with the impact assessment of river valley projects in the year 1978 to 79, and it is subsequently enhanced to cover other developmental sectors such as industries, thermal power project, mining schemes, etc. So environmental impact assessment has now been mandatory under the Environmental Protection Act. So various developmental projects have been categorized into category A and category B depending upon their capacity, threshold capacity, and the pollution potential. So it requires the environmental clearance from the Ministry of Environment, Forest, or Climate Change. So the concern, apart from this, you have the state environmental impact assessment authorities, and the clearance would be provided by the Ministry of Environment, Forests, and Climate Change. So there are several phases or several steps in environmental impact assessment process. So what are the different phases or the different steps? So it includes 7 important phases. First one is screening of the project. So here, the in this stage, the projects are listed and tried to identify those projects which have a considerable environmental impact. And next one is scoping. So considering the issues and impacts of environmental impact assessment. So then discussions, expert opinions are taken at this stage. In the third stage, that is the baseline data collection, it is the collection of the background information on the physical, social, and economic settings proposed project area. Then impact analysis and prediction, predicting the magnitude of a development, likely impact, and the significance is on the environmental process. Significant on environmental process is taken into consideration. So, and apart from this, you have, see, this impact analysis and product and prediction. It predicts the magnitude of a development of impact and evaluating their significance. It is one of the core of environmental assessment process. And then the analysis of alternatives. So alternatives is preferred if there is any impact on the environment by the concerned project. Then mitigation is to avoid or minimize or offset the predicted adverse impacts and to incorporate these into the environmental management plan or system. So next one is environmental management plan and environmental monitoring. See, similar to this environmental, similar to the EIA, that is environmental impact assessment, environmental planning, environmental legislature, these are also very, very important. So environmental monitoring is the systematic measurement of key environmental indicators. Just a minute, someone is entering here. Environmental monitoring is the measurement of environmental indicators over time within a particular environmental quality assessment and monitoring. So monitoring focuses on the most significant impacts identified in the environmental impact assessment. So you have 3 types of monitoring, namely the baseline monitoring, impact monitoring, and compliance monitoring. So what is baseline monitoring? See, baseline monitoring means a survey is conducted on the basic environmental parameters in the area surrounding the proposed project before the construction. So, impact monitoring means the biophysical and socio-economical parameters within the project area should be measured during the project construction and operational phases. Compliance monitoring means this form of monitoring employs periodic sampling a periodic sampling method or continuous recording of specific environmental quality indicators or pollution levels to ensure the project compliance with recommended environmental protection standards. So these are the three types of monitoring methods. So next one, yes, just a minute. Next one is environmental impact assessment. So this is the final report refer to the environmental impact statement. So most of the national environmental laws have specified the content of EIS. Multilateral and bilateral financial institutions have also defined what should be contained in the environmental impact statement. So the final one is the decision making. So at each stage of environmental impact assessment, decisions, interim decisions are made, which influences the final decisions of the EIA. So I'll repeat it once again. So these are the phases of the environmental project. Just a minute. This is the seventh one. So the phases of the EIA process, environmental impact assessment process, are screening, scoping, baseline data collection, impact analysis and production, analysis of alternatives, mitigation and impact management, environmental management, environmental monitoring, environmental impact statement, and decision making. So next one is environmental legislation. So what is this legislation? Laws, the rules and regulations. So it is an act of Parliament of India. So when the Bhopal tragedy, where the government of was Bhopal tragedy, when it was outbursted, the government of India enacted the Environmental Protection Act under Article 253 of the Constitution, and it passed in March 1986 and came into force on 19th November 1986. So the purpose of the act is to implement the decisions of the United Nations Conference on the Human Environments. They relate to the protection and improvement of the human environment and prevention of hazards to human beings, other living creatures, plants, and property. So, quality of environment for life on earth and man. See, maintaining the environmental quality is very important for the sustainable life on earth b- and also human beings. So, the environment directly affects the health of human beings and plays a major role in the quality of the life. So, poor air quality is linked to the premature death, long term damage to respiratory and cardiovascular system. Secondhand smoke. Secondhand smoke means the passive smokers. So, the secondhand smoke containing the toxic and cancer causing chemicals contributes to the lung cancer in non smoking adults. So, globally, nearly 25% of all the deaths and the total disease burden, it is due to the environmental factors. So, the deterioration of environmental quality with reference to anthropogenic impact. So, environmental degradation is a result of socio-economic, institutional, and technological activities. So, the environmental changes may be due to a number of factors, which includes the economic growth, population growth, urbanization, intensification, agriculture, intensification of agriculture, raising energy use, and transportation. So, poverty still remains a problem at the root of several environmental problems. So, the anthropogenic impact includes the social factors, the economic factors, and the institutional factors. So, what is environmental monitoring? See, it is a continuous observation of changes that takes place in the environment. It has a number of processes and steps to characterize and monitor the quality of the environment. So, monitoring may be carried out to assess pollution effects on man and his environment, to identify the possible cause and effect relationship between pollutant concentration, health effects, and climatic changes. So, to assess the need for legislative controls and emissions of pollutants and to ensure compliance with emission standards, environmental monitoring is very, very essential. So, what are the steps in a monitoring program? See, firstly, the site selection and the number measured parameters to be duration of a survey, the sampling methods, equipment selection, analytical techniques, calibration methods, data recording, data analysis, data presentation, information dissemination. So these are the different steps in the design of a monitoring program. So what are the types of monitoring? So the sources may be classified by their spatial distribution as point sources, as we discussed in the second block, line sources or area sources. So sources are also classified either statutory or mobile on the basis of height of discharge for air pollutants. Ambient air monitoring. So the quality of the air is monitored. It is required to determine the existing quality of air, evaluation of the effectiveness of control program, and to identify the areas in need of the restoration. So, guidelines for monitoring are made for carrying out ambient air quality monitoring at National Air Monitoring Program, and description of the program is essential and it is carried out to meet the objectives of NAMP. So, environmental water monitoring. So, similar to air, so the water has to be monitored. So, the pollutant enters into the aquatic environment. So, it enters into the water surface from the land and directly through the effluent discharges, either domestic, industrial, or agriculture. So these pollutants, in a natural way, it may be due to the stimulation of water plant growth. Stimulation of water plant growth means if there is a continuous input of nutrients in the water, there is a continuous multiplication of the phytoplanktons in the water bodies, which is called as eutrophication, which ultimately leads to deoxygenation of water. Deoxygenation of water means less amount of oxygen in the water due to eutrophication. See, when more and more nutrients it enters the organic pollutants, when it enters the water, so it stimulates the growth of the organisms, especially the phytoplanktons or the aerobic organisms which are present in the water. It multiplies, and this is called as eutrophication. So when it multiplies and when it requires more and more amount of oxygen, the oxygen in the water will not support these organisms for their survival, and hence the water becomes less in amount of oxygen. So these pollutants, they directly or indirectly, they are toxic to the aquatic life, and the particularly as a source of water for public supply. So the loss of amenity and practical value of water body, particularly as a source of water for public supply, is a great loss. So next one is sediment, soil and biological monitoring. So similar to the air and water, the soil and the sediments. Sediments means it may be the solid substance which settles in the bottom of the aquatic habitats. It becomes polluted by a number of ways, and the main pollution hazards on land from such contamination includes the harmful substances in the soil, the substances washed from the land, contaminates may be resuspended and it may be subsequently inhaled, and land may be potentially dangerous or unsuitable for future use either for housing or agriculture, and the ecological system may be damaged with consequent loss of conservation and amenity. So this also requires monitoring. So this is about the first unit. So the first unit, that is environmental quality assessment and monitoring. This is the first unit of block 4. So what is the definition of environment and deterioration of environment either due to natural ways or by man-made ways, the quality of the environment, environmental impact assessment, then the different phases or the different steps which are involved in the environmental impact assessment, and the environmental monitoring, which includes the baseline monitoring, impact monitoring and compliance monitoring, the environmental impact statement and decision making. So apart from the monitoring, you have also certain rules, certain legislations, and which is called as the environmental legislation, and the quality of environment for life on earth and man, deterioration of environmental quality with reference to anthropogenic impact, environmental monitoring, the steps in monitoring, types of monitoring, so air monitoring, water monitoring, sediment, soil, and biological monitoring. So this is about the first unit. So the second unit is the water quality assessment and monitoring. So water quality management is controlled by the authorization of discharges of dangerous substance for which monitoring of discharges, effluents and influenced surface water is essential. So, water quality monitoring is one of the first step which is required in the development and management of water resources. So, of course, it is a wide subject and it has scope, and it has a direct relation with the chemistry, biology, statistics, and also economics. So, its scope is also related to the types of water users and functions which are manifold, and the nature of source of water such as surface water, sea water, groundwater, etc. So, CPCB, the Central Pollution Control Board, is an apex body in the field of water quality management in India. So, water quality is a complex subject which involves physical, chemical, hydrological, and biological characteristics of water. So, water quality is defined as the physical, chemical, or biological characteristics of water by which the user evaluates the acceptability of water. See, for example, for drinking water, it should be pure, potable, and wholesome. Similarly, the irrigation, for irrigation, the dissolved solids and toxicants are important. For bathing, pathogens are important, and the water quality is controlled accordingly. So the quality of the water for different purposes, it varies. So textiles, paper, brewing, and other industries which uses water have their own specific water quality needs. So first coming to the drinking water, or it is also called as the potable water indicators. So the what are the indicators? See, alkalinity, the color of the water, the pH. pH means it is either alkaline, acidic, or basic. It is the hydrogen ion concentration. Taste and odor, dissolved metal salts, microorganisms, dissolved metals and metalloids, dissolved organic matter, then radon, heavy metals, pharmaceuticals, hormone analogs, etc. So these are the list of indicators which are measured for drinking water. So next one is environmental indicators. So environmental indicators, again you have the temperature of the water, TDS, total dissolved solids, specific conductance, odor of water, color of water, taste of water, total suspended solids, transparency, pH, heavy metals. So, biochemical oxygen demand, nitrate. See, it includes both physical and chemical indicators. Nitrate, COD, orthophosphates, dissolved oxygen, pesticides, hardness, surfactants, etc. So all these are environmental indicators. So next one is the guidelines for drinking water quality recommended by World Health Organization. It relates to the following variables. So, acceptability aspects, microbiological aspects, chemical aspects, and radiological aspects. So, coming to the acceptability aspects, again, here it is differentiated into the physical aspects and chemical aspects. So, physical aspects includes the turbidity, color, taste, and odor. So, whereas the chemical aspects, all this comes under the acceptability aspects. So, chemical aspects includes the chlorides, ammonia, then you have the hydrogen sulfide, then nitrogen, sodium, total dissolved solids, dissolved oxygen, zinc, copper, manganese, aluminium, etc. So the guidelines for drinking water quality, it relates to the following variables. First one is acceptability aspects. Second one is the microbiological aspects. So microbiological aspects, it includes the bacteriological, viral, and biological. So bacteriological means these are the bacteria, the fecal bacteria which pollutes the water. So drinking water should not contain any organisms which are pathogenic. Pathogenic means which cause diseases. So the primary bacterial indicator recommended for this purpose is the coliform. Coliform is the Escherichia coli bacteria present in the gut, and the other organisms are the fecal streptococci and clostridia, and sometimes useful in determining the origin of fecal pollution to assess the efficacy of water treatment process. So, from the microbiological aspect of view, if the water is contaminated with the coliform, fecal streptococci, and clostridia, then it is assessed that that water is not used, that water is not fit for drinking. So, coming to the virological aspects, so similar to the bacteriological indicators, even the drinking water should not contain any infectious viruses. So disinfection means adding certain chemicals to kill these organisms. So disinfection with zero point 0.5 mg per liter of free chlorine residual after contact period for at least 30 minutes. 30 minutes at pH. pH of 8 is sufficient to inactivate the virus. So we have in case if the infectious virus is present, then we have to add the chlorine in order to remove this virus from the water. So ozone has been shown to be effective viral disinfectant, preferably for clean water, but it is not possible to maintain an ozone residual in distribution system. So biological indicator, virological aspect, and biological aspects. So the guidelines for drinking water quality recommended by WHO has the following variables. First one is acceptability aspects. Second one is microbiological aspects. In the microbiological aspects, you have the bacteriological, viral, and biological aspects. So biological aspects, you have a number of the organisms other than the microorganisms. You have other organisms present in the water, again, which says that it is not good for drinking. So the one of the uh, biological aspect, the bioorganism, the living organism is the protozoa. See, protozoa, it is transmitted by ingestion of contaminated drinking water like entamoeba, histolytica, giardia, etc. So these are introduced into the water supply through human and animal fecal contamination. So drinking water should be free from these pathogenic intestinal protozoa. Similarly, helminthes, the infective stages of any parasitic roundworms and flatworms, it can be transmitted to man through drinking water. So it should be free from, the water should be free from these infective stages. Free living organisms. So free living organisms that may occur in the water supplies, it includes the fungi, algae, etc. So the most common problem with these are their interference, the interference in the operation of the water treatment process in municipalities. It forms an hindrance, it changes the color, taste, and odor of the water. So this is the biological aspect. So next one is environmental water quality. So environmental water quality, which is also called as the ambient water quality, it relates to water bodies like lakes, rivers, and oceans. So water quality standards for surface water, it varies due to different environmental conditions, ecosystems, and human uses. So toxic substances and high population of certain microorganisms can present a health hazard for non-drinking purposes such as irrigation, swimming, fishing, rafting, boating, and industrial uses. So these conditions affects the wildlife which use the water for drinking or an habitat. So modern water quality laws generally specify the protection of fisheries and recreational use and require as a minimum retention of current quality standards. So next one is how this water is treated before it is used for drinking. So there are four methods. See, you have three types of in a series the water is treated, and first one is the primary treatment, next one is the secondary treatment, and third one is the complete treatment. So the primary treatment is the first treatment of water, which includes four methods. First one is the chlorination. So first one is chlorination, second one is ozone treatment, third one is ultraviolet treatment, and the fourth one is membrane filtration. So all these are primary treatment of water. So chlorination. Chlorination is It is a method of adding the chlorine to the water, which kills the disease causing bacteria, but it has no effect on the spores and certain viruses like the polio, viral hepatitis, except in higher doses. So it oxidizes iron, manganese, and hydrogen sulfide. It destroys the taste and odor producing constituents. It controls algae and slime organisms and causes acid coagulation. So, this is the first primary treatment of water. So, next one is ozone treatment. So this, though the principle is very simple, so ozone is generated by passing pure oxygen through an ozone generator. Then it is bubbled through the gas diffuser at the bottom of an absorption column in a direction opposite to the flow of water. Retention or contact time with the water is critical, and the size of absorption of column depends on the water flow. So this is also one of the primary treatment of water. Third one is ultraviolet irradiation treatment. So this method is often used to treat drinking water. So commercial installations have been made to purify the seawater in large fish processing plants. The membrane filtration, osmotic membrane treatment methods are generally expensive. The combination of membrane treatment with UV treatment units. So, membrane filtration, which as we use at our homes, the filters with the UV reversible osmosis, they are available for domestic use. So all these are primary treatment. So next one is the secondary treatment. The secondary treatment of water, it mainly consists of sedimentation and filtration, which is followed by chlorination. So sedimentation can be carried out by holding the water in ponds or tanks. And the filtration, you have different types of filters like cartridge filters, rapid sand filtration, multimedia sand filtration, upflow filtration, etc. And finally, the water is added with the chlorine in order to disinfect. So third one is the complete treatment. It is also called as the tertiary treatment of water. So this is the final stage of the treatment of water. So here the complete treatment consists of the flocculation, coagulation, sedimentation, and filtration followed by disinfection. So flocculation and coagulation, it removes the contaminants in the water, which causes turbidity, change in the color, odor, taste, which cannot be removed by the sedimentation alone. And said some of the coagulants like alum, ferric sulfate, and ferric chloride is also used for flocculation and coagulation. And the resultant precipitate, when we add these chemicals, a precipitate is formed. So this precipitate is removed by sedimentation and filtration. And finally, disinfection is done again by chlorine. So this is about the second unit regarding the water water quality monitoring, and water quality assessment and monitoring. So here we have discussed the quality of the water, the indicators of drinking water, the environmental indicators, which includes both physical as well as the chemical indicators, and the guidelines for drinking water quality recommended by WHO. So it has the acceptability aspects, microbiological aspects, chemical aspects, and radiological aspects. Acceptability aspects includes both physical and chemical aspects. Then microbiological aspects includes the bacteriological, virological, and biological aspects. And we have discussed the environmental water quality, excuse me, and the treatment of water, which includes the primary treatment, secondary treatment, and the complete treatment or tertiary treatment. So this is the second unit. Next, the third unit is air quality assessment and monitoring. So it is a process where the effect of air pollution and on environment and human health is assessed, and the steps that are taken to ensure the ill effects which can be mitigated. So there are two types of air quality monitoring. One is ambient air quality monitoring, and the other one is indoor air quality monitoring and testing. So in this unit, so we are going to study the different air pollutants. So what are the different air pollutants which is required, which requires monitoring, and their environmental impact and the health impact. So you have a number of air pollutants. So first one, yes, the particulate matter. So the atmospheric particulate matter with a diameter less than 2.5 micrometers is called as fine particulate matter. So the coarse particulate matter has a diameter of less than 10 micrometers. So if the diameter of the particular particulate matter is less than 2.5 micrometers, it is called as the fine particulate matter. If the diameter is less than 10 micrometers, then it is called as coarse particulate matter. So these fine particles, they are generally produced from anthropogenic human activities, which includes the power plants, motor vehicles, aeroplanes, residential wood burning, forest fires, volcanic eruptions, and dust storms. So it varies with the size and shape, and they are made up of different chemicals. And most of these, they are found in the atmosphere because of the complex reactions of the chemicals. So these coarse particulate matter, so 90% of this particulate matter is not visible to the naked eye, and it causes less severe health effects, mostly in the respiratory tract. So, what is the environmental impact of this particulate matter? It creates acidic water bodies, it damages the stone and other materials, it damages the historical buildings, including statues and monuments, and the nutrient imbalance in acidic waters, which leads to the impacts on coastal water and the flora and fauna. Flora and fauna means the plants and animals residing in the water bodies. So, what is the health impact of this particulate matter? So, as they are very light in weight, they live longer in the air when compared to the heavier particles. So these lighter particles, they are inhaled by human beings and animals, and these particles penetrate into the respiratory and circulatory system. So which leads to the premature deterioration of heart and lungs, which causes chronic disease such as asthma, heart attack, bronchitis, and other respiratory problems. So the next important air pollutant is sulfur oxides. So these sulfur oxides are the major form of sulfur oxides is the sulfur dioxide. So it is a colorless gaseous form which is found in the lower atmosphere. So the sources of this sulfur dioxide are the burning fuels containing sulfur, roasting metal sulfide ores, so burning of high sulfur coal, and heating oil in thermal thermal power plants, and natural sources like volcanoes of sulfur dioxide, emission from industrial boilers, emission from industrial boilers, then emission from domestic coal burning vehicles, which contribute to the high ambient concentration of sulfur dioxide. So, these are the important sources from where the sulfur dioxide is released into the atmosphere. So, what is the health impact of this sulfur oxide? So, when sulfur oxide enters into the atmosphere, it enters into the human beings through the lungs through inhalation, and it causes respiratory diseases, then irritation of the eyes, nose, throat, premature mortality in children as well as the elderly people. So next is in order to prevent, how to prevent this? In order to prevent getting affected due to sulfur oxides, so the some of the protective equipments and measures that has to be undertaken are so so we have to wear a chemical safety goggles and face shield when contact is possible or in workplace, then use of protective gears like chemical protective clothing like gloves, aprons, boots, etc. So any chemical cartridge respirator providing protection against sulfur dioxide for respiratory protection. So the next one is nitrogen oxides. So nitrogen dioxide and nitric oxide together we call it as nitrogen oxides. So when this nitrogen is released during the combustion process, it combines with the oxygen and it forms nitric oxide. So it further undergoes oxidation to form the nitrogen dioxide. So in urban areas or in the metropolitan cities where there is a heavy traffic, the amount of nitrogen oxides emitted into the atmosphere increases and it causes air pollution. So this nitrogen dioxide, it discolors the fabrics and are also it is very harmful to the vegetation. It reduces the visibility, it damages the foliage, decreases the yield of the crops. So the health impact of this nitrogen oxide is it can cause burning of the skin and possible high damage. Breathing can irritate nose and throat as well as the lungs, which causes coughing, breathing problem, etc. So high level of exposure may affect the ability of the blood to carry the oxygen, resulting in headache, fatigue, dizziness, and blue color to the skin and the lips. So the precautionary measures includes the local exhaust ventilation and the protective gears like suits, gloves, footwear, headgear, goggles in the workplace, and immediately washing when we are exposed to the nitrogen dioxide, and training and training and communication about the health and the safety hazards of nitrogen dioxide to potentially exposed workers is very important. So these are some of the precautionary measures of nitrogen oxides. So, like this, we have a number of pollutants which harm the human health and, of course, the environment. So, another important pollutant is the volatile organic compounds. So, these volatile organic compounds or the organic compounds which contain one or more carbon atoms that have high vapor pressure and gets evaporated readily into the atmosphere. So the concentration of these volatile organic compounds, they are found much higher in indoors in the enclosed environment than the outside. So thousands of the products emits a wide range of volatile organic compounds. So in household products, many of the organic chemicals are widely used as ingredients like paints, varnishes, fuels, wax, which consists of these organic solvents, which are used for cleaning, disinfecting, degreasing, and hobby products. Say many volatile organic compounds are acetaldehyde, acetone, benzene, carbon tetrachloride, ethyl acetate, ethylene glycol, formaldehyde, etc. So the environmental impact of these volatile organic compounds are, so the agricultural crop, the yield of agricultural crop is reduced, and the commercial forest yields is reduced. So reduced growth and survivability of the tree seedlings, increased plant susceptibility to disease and pests, and it also causes unpleasant weather conditions. So the health impact of this organic compounds may have short and long term adverse health effect, as each chemical has its own toxicity and potential for causing different health effects. So next pollutant is carbon monoxide. Carbon monoxide is, see, most of these air pollutants are the greenhouse gases. Carbon monoxide is a colorless, odorless, tasteless, poisonous gas. It is produced from the incomplete combustion of carbon containing compounds, mainly in the internal combustion engines. So, the incomplete burning of natural gas and any other material containing carbon, such as gasoline, kerosene, oil, coal, wood, produce carbon dioxide, which is a common industrial hazard. So, the environmental impact of carbon monoxide, yes, it affects the concentration of greenhouse gases, including methane, ozone, carbon dioxide, which contributes to the unbalanced atmospheric temperature. So undesirable climate change is also one of the reason of the excessive emission of this carbon monoxide. So carbon monoxide, it remains in the body for a long time, and as a result, if there is an increase in the level of carbon monoxide, it reduces the amount of oxygen carried by the hemoglobin in the body in the red blood cells and causes asphyxiation. The result is that it causes the brain, nerves tissues, and the heart, it will not receive enough amount of oxygen to work properly. So next one is ammonia. Ammonia is a highly reactive and soluble alkaline gas. It originates from both natural and anthropogenic sources, with the main source being the agriculture. The breakdown and volatilization of urea also produces ammonia. So this ammonia, high levels of ammonia is toxic to both animals, birds, fishes, and also the plants. So it is toxic to the alkaline water, as there is an increase in the level of pH, decreases the concentration of oxygen. So thus it becomes toxic to aquatic organisms, and high concentration of immediate burning of the nose, throat, and ammonia exposure respiratory tract is very common in higher doses to human beings. So next one is the ozone. Ozone is composed of three oxygen atoms, which is a highly reactive gas, which is toxic, oxidative, unstable, with pungent odor. So you have two types of ozone here: ozone, good ozone, and the bad ozone. So the in the stratosphere region, we see the good ozone. Bad ozone is seen in the troposphere region. So this ozone layer, it is partially destroyed by man-made chemicals, and it results in the ozone hole. Ozone hole. So next one is the impact of this ozone. So ground level ozone, that is the ozone which is present in the troposphere. It is called as the bad ozone. It affects the water cycle, nutrient cycle, and it makes the plants more vulnerable to diseases, insects, pollutants, etc. So, irritation in the respiratory system, which causes the coughing, throat irritation, uncomfortable sensation in the chest, lung, reduced lung function, difficulty in breathing, etc., are all the health impact of ozone. So it is more aggressive for asthma patients and those who are sensitive to allergens and triggers it help and it triggers the asthma attacks. So these were the some of the pollutants. So how to assess the quality of the air? There are a number of tools to assess the quality of the air. First one is the urban air quality management plan is an effective and efficient tool which is employed in managing the acceptable urban air quality. So many developed countries have their own urban air quality management plan. So developing countries are still working in formulating the effective and efficient urban air quality management plans. So it is formulated in two steps. First step is to identify the air quality control regions, and the second step is to initiate a time bound program involving all stakeholders to develop the air quality management plan. So next one is emission inventory. This is another tool which is used for the management of atmospheric environment. So an inventory emission tool, it calculates the quantity of air pollutants which are emitted and the source of its generation. So it is one of the most indispensable tool for a wide range of environmental measures such as management of chemicals as well as the prevention of air pollution. So next one is dispersion modeling. It is another quality model which is used in permitting process to estimate the concentration of pollutants at specified ground level receptors surrounding an emission source. So this is about the third unit. The third unit, that is air quality assessment and monitoring. So air quality monitoring is of two types: ambient air quality monitoring and indoor air quality monitoring. So you have different air pollutants. They are like particulate matter, the environmental impact of these pollutants, health impact of these pollutants, particulate matter, sulfur oxide, nitrogen oxide. Then you have the volatile organic compounds, carbon monoxide. Then you have the ammonia, ozone, and the air quality assessment tools. So all this we have discussed in the third unit. So next one is the fourth unit. So the fourth unit of block 4, it deals with the soil quality and noise assessment and monitoring. So in the first unit, we discussed the environmental quality assessment and monitoring. In the second unit, water quality assessment and monitoring. Third one is air quality assessment and monitoring. The last one, the fourth one, is soil quality and soil quality and noise assessment. Soil quality and noise assessment and monitoring. So here we are going to study about the types of soil, how the soil is formed, and how the noise, what is the difference between the noise and noise and sound, and how it is assessed and monitored. See, the maintenance and improvement of soil and noise quality is important for environmental sustainability. So in this last unit, we are going to study the quality of the soil, the salinity, organic matter, volatile organic chemicals, heavy metal, and the noise assessment and the noise monitoring, etc. So first let us take up the quality of the soil. Soil quality. So soil quality is the capacity of the soil to function within the ecosystem boundaries to sustain biological productivity, maintain environmental quality, and promote plant and animal health. So the factors which causes the soil quality degradation are considering the soil threats, the assessing the quality of the soil system becomes very essential. So the major threats faced by the soil are soil erosion. Soil erosion means the removal of the top layer of the soil, which is very important for the fertility of the soil. Soil contamination. So it is contaminated with a number of pollutants. Decline in reduction in organic matter and biodiversity. Soil compaction, excuse me, salinization, floods and landslides, and finally the soil sealing. So these are some of the threats faced by the soil. So types of soil assessment tools. So first one, yes. So what are the different types of assessing the soil quality? First one is infiltration. So in this measurement, it measures how fast the water can infiltrate into the soil. The second one is the bulk density. So it measures the weight of the soil per volume of soil. So it is an indicator how well the plant seedlings can emerge and how well the air can circulate through the soil. The third one is the pH, that is the hydrogen ion concentration of the soil water. So it determines whether the soil water is acidic, neutral, or basic. Next one is electrical conductivity. It indicates how much salt is present in the soil and how well an electric current can travel through the soil water. Next one is the nitrate. It measures how much nitrate is present in the soil, and it is an indicator of the availability of the important plant nutrient, the nitrogen. So next one is aggregate stability. So it is an indicator how well the water can infiltrate into the soil during rainfall or irrigation, and how easily soil is washed off or blown away. So next one is the slaking. Slaking means how fast the soil particles disperse in water is measured by slaking. So slaking is an indicator whether and how fast a soil will form slurry during rainfall or irrigation. So these are some of the soil quality assessment tools. So how to improve the quality of the soil? So some of the important ways by which we can improve the soil quality are: first one is addition of organic matter. So regularly adding the organic matter improves the quality of the soil by improving the water holding capacity and nutrient availability, and it protects the soil against erosion. Secondly, it avoids excessive tillage. Tillage has a positive effects, but it also triggers excessive organic matter degradation, and it disrupts the structure of the soil. Third one is management of fertilizer and use of these pesticides. It can increase the plant growth and amount of organic matter returned to the soil. And ground cover increase. Ground cover means the bare soil. When it is free from the soil is free from any growth of the plants, it is susceptible to erosion either by wind or water, and it causes drying and crusting. So water availability can be improved by the soil organisms, especially the insects and the earthworms. The cover crops means the crops which covers the soil surface. Perennials and surface residue increase the amount of time that the soil surface is covered each year. Increase in plant diversity. So each crop contributes a unique root structure and the type of residue to the soil. See, plants, they do not have an excretory system. So it is exuded out through various parts of the plant body, especially through the roots. So uh, attracted by these nutrients which is released through the roots, a number of soil organisms, they come and attach to these substances, and this zone is called as the rhizosphere region. So these soil organisms, they control the pest population, and the diversity of cultural practices can reduce weed and disease pressures. So plant diversity over time can be increased by using the buffer strips, small fields, contour strip cropping, crop rotation, and with a number of different tillage practices. So next one is the organic matter. See, soil contains a mixture of weathered rock particles and organic matter. Weathered means powdered rock particles plus the organic matter together we call it as the soil. So organic matter consists of decomposing plant and animal residues. In addition to these materials, soil organic matter contains living and dead microbial cells, microbially synthesized compounds, and a number of derivatives produced as a result of microbial activity. So the organic matter is nothing but the dead and decomposing organic matter, the dead animals, plants, then the twigs, branches, and some of the animal excreta. All these together we call it as the organic matter. So the soil organic matter, it originates from plants, animals, and microorganisms. So the leaves and roots of trees. Then you have the shrubs, grasses. Then you have the dead and decaying animal life, earthworms, centipedes, insects. Then you have the ants, which play an important role in forming the plant residues. So when organic matter is broken down into a stable substance that resists further decomposition, and it is called as the humus. So soil organic matter plays an important role in contributing the fertility of the soil. So, heavy metals. These are generally defined as the metals with high density atomic weight and atomic numbers. So, in metallurgy, a heavy metal may be defined on the basis of density, whereas in physics, the distinguishing criteria is the atomic number, while a chemist would likely to be more concerned with the chemical behavior. So the known metals, the common metals such as iron, copper, tin, and precious metals like silver, gold, platinum, all these are heavy metals due to their high density, high atomic weight, and atomic numbers. So this heavy metal poisoning, the sources of this heavy metal poisoning include the mining, then industrial waste, agricultural runoff, occupational exposure, paints, and treated timber. So, what is the adverse effect of heavy metals on human health? So, you have a number of heavy metals, of which the vanadium pentoxide is carcinogenic to animals, and when it is inhaled, it causes DNA damage. So manganese tetroxide is poison for liver and kidney. And ingesting means eating zero point 0.5 grams or more of iron. It can cause cardiac collapse. And 30 parts per million ppm of nickel carbonyl. It can cause respiratory failure, brain damage, and death. So, imbibing a gram or more of copper sulfate is fatal. So, survivals may be left with major organ damage. So, 5 grams or higher of selenium is highly toxic and can cause paralytic effects. So, volatile organic chemicals, which are ubiquitous in both outdoor and indoor, it originates from construction materials in addition to outside sources like vegetation, bioeffluents, occupant activities, and building maintenance. So, the environmental and climatic impacts of these volatile organic compounds in urban areas, it results in the formation of a photochemical smoke. So, the photolysis of nitrous acid can also be a significant source of OH and in highly polluted regions. These radicals react with the trace constituents. The oxidation rates of volatile organic compounds are much faster than the relatively abundant trace gases like methane and carbon monoxide. So, the noise level monitoring. So here also similar to the air, water, soil monitoring, you have the noise level monitoring policies or acts. So the National Environmental Policy, the ambient noise includes the noise as an environmental quality parameter and it should be monitored in urban areas. So, Central Pollution Control Board developed National Ambient Noise Monitoring Network Program, which includes the installation of noise monitoring stations all over India. It is a process to measure the magnitude of noise in industries and residential areas. So there are a number of noise measuring instruments. So the most common instruments for measuring noise are sound level meter, integrated integrating sound level meter, noise dosimeter, etc. So it is important to understand the calibration, operation, and the reading of this instrument before use. So this the last unit, that is the fourth unit, the soil quality and noise assessment and monitoring. It includes similar to the soil and air. You you're going to study the soil quality, types of soil quality assessment tools, and some of the practices which improve the soil quality, and the heavy metals, effect of heavy metals, volatile compounds, the impact of volatile compounds, then noise level monitoring and noise measuring instruments. So in block 4, you have 4 units. The first one is environmental quality assessment and monitoring. Second unit deals with the water quality assessment and monitoring. Third one is the air quality assessment and monitoring. And the fourth one is soil quality and noise assessment and monitoring. So let us brief it out all the units of the block 4. First one is environmental quality assessment and monitoring. So in this we have studied the environmental quality, EIA, environmental impact assessment, the phases which are involved in the environmental impact assessment, then environmental monitoring. You have 3 types of environmental monitoring. Then the environmental legislation, quality of environment for life on earth and man, deterioration of environmental quality with reference to anthropogenic impact, environmental monitoring, steps in the design of program, types of monitoring, ambient air monitoring, environmental water monitoring, sediment, soil, and biological monitoring. So in the second unit, the water quality assessment and monitoring. So we have discussed the quality of water, drinking water indicators, environmental indicators, and then you have the guidelines for the drinking water quality recommended by WHO, which
In this, ma'am, radiological aspects, there is no explanation for that.
just a minute, I'll see. Acceptability. Yeah, it's there, but it is too lengthy. So I thought I will cut short it. It has radiological aspects when compared to the acceptability, microbiological and chemical. It is too lengthy. If you want, I will deal this in a very short lecture in the next class.
There is nothing in the book about that.
No, no, it's there. It's there. Not in the book, but you can get it from the internet. A number of
Okay.
radiological
Okay.
aspects. If you want,
Okay.
otherwise, I can make a notes and I can send it to you.
Yeah. Yeah.
Okay.
Okay, ma'am.
Acceptability aspects, microbiological aspects, the biological aspects, environmental water quality, and the different types of treatment of water. You have the primary, secondary, and the complete treatment. And the third unit, you have the air quality assessment and monitoring, which deals with a number of pollutants, air pollutants, the environmental impact, the health impact, the sulfur oxides, and then you have the nitrogen oxides, and then you have the volatile organic compounds, carbon monoxide, ammonia, ozone, then air quality assessment tools, emission inventory, and dispersion modeling. And the next unit, that is the noise monitoring and assessment and the soil quality. You have the types of soil quality assessment tools and the steps for the improvement of soil quality, and you have the heavy metals, the volatile organic chemicals, environmental and climatic impacts of volatile organic compounds, noise level monitoring, and noise measuring instruments. So this is about the block 4, which has all the units, 4 units, all the 4 units. So in the next class, I'll take up the next block. The next block, just a minute, I'll take the attendance. Wait for a few minutes, I'll take the attendance. Thank you all. Thank you for